Hello students, in this video I am going to explain the concept of sets. I will split into 6 different concept videos. The first video is based on definition, notation, and what is the definition of element and what is the definition of notation, what is the purpose of epsilon symbol, and different representation of sets. There are 2 types of representation of sets. One is roster form or list form, another one is set builder form and rule form, and the standard set notations. Okay. So first we will discuss one by one. Set. A set is a well-defined collection of objects. A set is a well-defined collection of objects. So what is the meaning of well-defined? For example, set of students who scored above 90% are called brilliant student, then it is a set. Set of all brilliant students in a class, it is not well defined. Reason is, if I give some condition for well defined, condition for brilliant, then it is well defined. Okay. So collection of, that is well defined collection of objects. If it is not well defined, it is not a set, it is just only a collection. The difference between collection and set, set is well defined collection and collection may or may not be well defined. Okay. And notation of sets. For example, sets are usually denoted by capital letters A, B, C, X, Y, Z, capital letters. For example, set of natural numbers less than 5, 1, 2, 3, 4, 5. This is an example. Another set of even numbers, even prime numbers. The only even prime number is 2. These 2 are the examples for set. Here it is well defined, because here why it is set? Because it is a well defined collection. Natural numbers less than 5. Natural numbers less than 5. And second one is also well defined because it is an even prime number. Even prime number. And notation of sets is, we can use capital letters, that is either A, B, C or X, Y, Z. And 1, 2, 3, 4, 5, these numbers are called members, objects or elements. You can use any word, but throughout the discussion I am using elements. So elements is nothing but members or objects of a set. Notation for elements or members, same as this. Here it is capital letters, here it is small letters. Capital letters for set notation and for elements notation, small letters. So this is a concept of set and notation of set, definition of element and notation of element. So what is a set again? Well defined collection of objects. Well defined collection of objects. Set of collection of dangerous animals in a forest. Is it a set or collection? Yes, it is a collection. It is not a set. Reason is, it is not well defined. For dangerous, if I give some condition, then it is, the collection becomes set, otherwise it is collection only. Okay. Next, suppose A equal to natural numbers less than 3, less than or equal to 3. Okay. So this is set. Here 1 belongs to A, 2 belongs to B, 3 belongs to B. 1 belongs to A, 2 belongs to A, 3 belongs to A. We can write 1 belongs to A, 2 belongs to A, 3 belongs to A. 4, there is no 4 in this set, and hence we can use this symbol, does not belongs to. The name of this symbol is, Greek symbol is called epsilon. The purpose of epsilon is belongs to. So we can use this epsilon symbol only for an element. If an element belongs to that set, you can use this epsilon symbol, and this is does not belongs to. This is the purpose of this Greek symbol epsilon and does not belongs to. So in 11th standard, you need to learn a lot of Greek letters like English alphabets, capital Greek alphabets and small Greek alphabet. This is one of the small Greek alphabet, epsilon for elements, belongs to that or does not belongs to that. Okay. Next, representation of a set. We can represent set in 2 different ways. One is a roster form or list form. Roster form or list form. So what is the meaning of roster form or list form? In roster form, all the elements of a set are listed and the elements are being separated by commas. Elements are being separated by commas and enclosed within braces. And enclosed within braces. All the elements of a set are listed, the elements are being separated by commas and enclosed within brackets. Now A equal to A, E, I, O, U. This is set of vowels in an English alphabet. Set of vowels. And B equal to 1, 2, 3, 4, 5, 6. Assume that it is a outcome when a die is thrown. Outcome when a die is thrown. So in roster form or list form, you have to list all the elements and enclose within the braces. This is a definition of roster form. Next, and one more condition in roster form. In roster form, the order in which the elements are listed is immaterial. For example, this is 1, 2, 3 and you can write 3, 1, 2 or 1, 3, 2. All are equal. You can write in any order, all the three. See, for 3 numbers we can arrange in 6 ways, but all the 6 ways is nothing but, suppose if I assume this is B, then all the 6 arrangements, everything is denoted by the capital letter B. Reason is, order is immaterial in a set. This is very important note. In roster form, the order in which the elements are listed is immaterial. For example, 1, 2, 2, 1. Equal only. Order is immaterial. Both are not different, both are same. Next, it may be noted that while writing the set in roster form, the element is not generally repeated. That is, all the elements are taken as distinct. For example, 1, 2, same as 1, 2, 2. Both are equal only because repetition not allowed. Repetition not allowed. So, very important condition for repetition of an element. For example, 1, 2, 1, 2, 2. So this represents the same set only because repetition generally not allowed. So 2 important note in roster form, you can write in any order. That is very important. Okay, you can write in any order and repetition not allowed. Repetition not allowed in subset note symbol. Okay, if you enclose within the braces, so don't repeat the numbers because repetition not allowed. Another form, another representation of a set builder form or rule form. Set builder form or rule form. In set builder form, all the elements of a set possess a single common property which is not possessed by any element outside that set. Any element outside that set. Previously, see here A, E, I, O, U. Now, the same set of all x such that this symbol is used for such that. How to read? Set of all x such that x is a vowel of an English alphabet. So in roster form you have to list all the elements, whereas in set builder form write the condition, common property. What is that property? The property is vowels of an English alphabet. And second one, set of all x such that x less than 7 and x less than 7, x belongs to n. All natural numbers less than 7. What are the natural numbers less than 7? Natural numbers less than 7 is 1, 2, 3, 4, 5, 6. This is roster form or list form. But if you write this way, it is called a set builder form. So here, single common property. That common property is a natural number less than 7. That is a common property. But all the 6 numbers satisfy this condition. And very important, we can use such that. For such that, you can use this or colon. Both are either colon or such that. And very important note using set builder form, the elements of a set by using symbol X or any other symbol like the letters Y, Z, etc. could be used, which is followed by a colon. So, colon or such that, colon or such that. After the sign of colon, we write the characteristic property possessed by the elements of the set and then enclose the whole description within braces. Property, element, very important, element such that, property enclosed within the bracket. For example, set of, for example, S equal to set of all X such that X equal to n square, n belongs to n and n less than 4, which is equal to 1 square comma 2 square comma 3 square, that is equal to 1 comma 4 comma 9. So, very important property. And what is the purpose of this advantage of this set builder form? Whenever the set is infinite, you can't list all the elements. So, in that case, roster form or list form is not easy. So, you can use this set builder form. This is one very important advantage of set builder form. Okay. Now, so this is a lower class concept only. We will revise this concept. Set of natural numbers starts from 1, 2, 3, 4 and so on. And is one more name for natural numbers? Any idea about one more name of natural numbers? Yes, counting numbers. One more name for natural number is counting numbers. So, n and whole numbers. Natural number along with 0, that is whole numbers. And integer, whole number along with negative of natural numbers. 0, 1, 2 and this side -1, -2 up to -infinity. And very important, whenever the set is infinite, this is very important note, do not forget, whenever the set is infinite, if you want to write in roster form, write first 3 numbers, comma 3 dots, which means up to infinity, up to infinity. So, first 3 numbers, comma and then 3 dots. Next, here both sides 3 dots because left side up to -infinity, right side up to +infinity. Then z plus equal to 1, 2, 3 positive integers and z minus negative integers -1, -2 up to -infinity on the left side. And rational numbers, set of all x such that x equal to p by q, p and q are integers and q not equal to 0, that is very important. And rational numbers, set of all x such that x is a real number but it is not rational, that is very important. The complement of rational numbers is irrational. The combination of rational and irrational is nothing but what? Real numbers. Okay. All real numbers other than the rational, which means non-terminating, non-recurring numbers in decimal form format. And a set of all real numbers, R plus set of positive real numbers, and C is set of complex number. This is a new number system. Okay, we will study in detail in chapter 5. Very important chapter. So far, till 10th standard, you have number system till R. Natural number, whole number, 1, 2, 3, 4, 5. And here R, 6. Now we have a new number system called complex number system. We will discuss in detail in chapter 5. So far we discussed the definition of sets and what is the notation for set and definition of an element and what is the notation for elements and what are the different representation of sets and what are the different number systems using alphabets, how to represent that number system. At present we will discuss the level 1 concepts of set language. I hope you can easily revise this concept. Hello students, now I am going to explain the types of sets. Types of sets I will classify into 2 different video. First, this video I will teach What are the basic types of sets? One, empty set, null set or void set. Second one is singleton set. Third one is finite set. Fourth one infinite set. And fifth one equivalent sets. Sixth one equal sets. First, what is empty sets? Empty set, null set or void set. So you can use any word. Set containing no element is called empty set and is denoted by Greek letter. Very important, either empty bracket or Greek letter phi. For example, set of natural numbers less than 1. Set of natural numbers less than 1. So what are the natural numbers less than 1? Less than 1 there is no natural number and hence it is an empty set. See here, set of all x such that x plus 6 equal to 2, x equal to 2 minus 6 equal to minus 4. But here x is a natural number, this is not a natural number, does not belongs to n and hence it is a null set. It is a null set. A set which has no element is called a null set, void set or empty set. Okay. Singleton set. A set containing exactly one element. A set containing exactly one element is called a singleton set. A set containing exactly one element is called a singleton set. That is, set of even prime numbers. Set of all x such that x is an even prime number. The only even prime number in number system is 2. 2. Set of even prime numbers or set of natural numbers less than 2. So what are the natural numbers less than 2? Set of natural numbers less than 2, that is 1. Set of natural numbers less than 2. What is empty set? What is singleton set? Third, finite set. A set containing finite number of elements is called a finite set. Finite number of elements is called a finite set. And one important word in this, cardinal number. Total number of elements in a finite set is called the cardinal number of set and is denoted by n of a. For example, set of all x such that x is a prime number less than 10. So what are the prime numbers less than 10? What are the prime numbers less than 10? This is A. Prime number less than 10 is 2, 3, 5, 7. Prime number less than 10. And n of A, number of elements in A equal to 1, 2, 3, 4. 4 numbers are there. So this is A. This is A. And cardinal number of A, that is n of A equal to 4. N of A equal to 4. Okay. Cardinal number. Infinite set. A set is an infinite set. A set is called infinite set if the number of element in it is not finite. That is, it has infinite number of elements. Set of all x such that x is a natural numbers. So what are the natural numbers? 1, 2, 3, 4 up to infinity. It is not finite, it is an infinite set. But in higher studies you have two more sets is there. That is, one is countable set, another one is uncountable set. Countable set and uncountable set. You will study in your higher studies. But at present in 11th standard you have finite or infinite. For finite you have one additional concept called cardinal number. Cardinal number of a set is nothing but total number of elements in that set. Total number of elements in that set and is denoted by n of A. But here also n of A. So how many sets, how many elements it has? It has infinite number of elements. Infinite number of elements. Next, very, very important. These were the major important for your school exams. Equivalent sets. Two sets A and B are said to be equivalent sets if they contain same number. This is very important. Same number of elements and is denoted by A equivalent to this. For example, A equal to 1, 2, 3 and B equal to A, B, C. Here A is equivalent to B. Reason? Here the elements are numbers, but here the elements are alphabets. Even though different elements, different category of elements, both are equivalent because of the definition. What is the definition? Same number of elements. So what is n of A? N of A equal to 3. And what is n of B? N of B equal to 3. If total number of elements are same in both the sets, then those two sets are called equivalent set, irrespective of the type of elements. Maybe in alphabets, one set may contain numbers, equivalent set. And here also 1, 2, 3, 2, 3, 1. So you can say this as equivalent. But after this definition, this is equal set. Reason I will explain. Equal sets. Two sets A and B are said to be equal if they contain, see the difference, same number of elements, same number of elements, same number of elements, whereas here same elements, same elements, same elements, same number. It depends only on the cardinality, but here same elements. For example, A equal to 1, 2, 3 and B equal to 2, 1, 3. Both have 3 elements, but same elements. Here 1, 2, 3, here 2, 1, 3. Already we discussed in the previous video, order is immaterial in a set. That is very important. Order is immaterial in a set. So both are equal. So equivalent sets and equal sets. Equivalent sets concept based on the cardinal number, that is same number of elements, whereas for equal set same elements. That is very important condition. So in this video we discussed basic types of sets. So what is empty set? A set which contains no element is called empty set and is denoted by two different representation. One is empty braces, another one is Greek letter phi. And a singleton set, a set which contains only one element. Third, finite set, a set which contains finite number of elements, otherwise it is called infinite set. And type 5, equivalent sets. Two sets are said to be equivalent if they have same number of elements, And the sixth type, two sets are said to be equal if they have same element. This is same and this is same number of elements. That is very important. So this is first category of types of sets. So in the next video we will discuss more types of sets and more operations also. I hope you enjoy this video and you are clear about type 1 sets. Thank you. Hello students, so in this video I will teach some more types of sets. Previously we discussed 6 types of types, now we will discuss 5 types of sets. But everything based on one important definition called subset, and based on that proper subset, improper subset, universal set and power set. First we will discuss what is subset. A and B are sets if every element of A is an element of B. Every element of A is an element of B, then A is called a subset of B. Thus this symbol is for subset, contained in or equal to, if and only if, very important word, if and only if. That is, every element in A is also an element of B. Every element A is an element of B. A belongs to A implies, this is A. A belongs to A implies A belongs to B. So this is definition of subset. So in Venn diagram wise, or otherwise I will write one example, A equal to 1, 2 and B equal to 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now, what are the elements of A? 1 belongs to B, 2 belongs to B, but B has 2 elements more than A, and hence A is smaller set. All the elements of A belongs to B, and hence A is called a subset of B, and B is called superset of A. A is called a subset of B, and B is called a superset of A. We can represent sets using Venn diagram. In the later video I will explain in detail, but using Venn diagram, how to draw the circle for subsets. For example, B has 4 elements, 3, 4, and this is 1, 2. Now look at the figure, what are the elements does A contains? A contains 1 and 2, and B contains 1, 2, 3, 4. And what is the difference of 3 and 4? 3 and 4 belongs to B, but that does not belongs to A. Okay, this is diagram for subset, Venn diagram for subset. And proper subset, very important word, proper subset. Set A is a proper subset of B and is denoted by this. A is a proper subset of B. If all the elements of set A are elements of set B and set A not equal to set B. All the elements of set A are the elements of set B and set A not equal to set B. That is, set B must contains at least one element not in the set A. For example, here A is a proper subset because all the elements of A belongs to this, but A and B are not equal. Okay, B has extra element. So here A is a proper subset of this. This is proper subset. Contained in, and this is contained in or equal to. This is similar to less than or equal to in number system. Okay, contained in for proper subset, contained in or equal to for subset. Okay, what is subset? What is proper subset? If it is not proper, then what is the name of the complement? Improper subset. Set A is an improper subset of B and is denoted by A contained in or equal to. If and only if all the elements of set A are the elements of set B and set A equal to set B. In the previous definition, this is not equal, but here it is equal, set A equal to set B. Example, a set itself is an improper subset. A set itself, it is an improper subset. For example, A equal to 1, 2, 3 and B equal to 3, 1, 2. So A is a subset of B and B is a subset of A. Actually, one theoretical definition for equal sets, if A is a subset of B and B is a subset of A, then only A equal to B. Then only A equal to B. Condition for equality, one is a subset of other and I say opposite set is a subset of this. A is a subset of B and B is a subset of A, then A equal to B. So this is condition for improper subset. One important formula for improper subset and proper subset we will discuss in the another video, but we will discuss two more sets. One is universal set. A set containing all the objects or elements, and of which all other sets are subsets. For example, A equal to 1, 2, B equal to 3, 4, C equal to 1, 5, D equal to 1, 2, 3, 4, 5. See the example, A has 1 and 2, so A is a subset of D, B has some other 2 elements that is also belongs to D, and C equal to 1, 5, that is also D. D is a superset of A, B and C, and hence we can say D is a universal set. Universal set is a set, again read the definition, a set containing all objects or elements and of which all other are subset. Yes, A, B, C are all subsets of D and hence D is a universal set. We can use special symbol for universal set, U, capital U. So otherwise we can use these two, but follow this symbol capital U for universal set. So far we have two special symbol, only for two types we are using special symbols. One is universal set capital U, another one is null set, that is by using Greek letter. Power set. Set of all subset of a set is called a power set and is denoted by P of A. For example, this is one of the very important concept for your exam. A 1, 2, 3. Write all possible subsets, either one element alone or two element or all three elements or no elements. Start with no elements. A subset which has no element. A subset which has only one element. okay, and subset which has two elements, 1 comma 2, 2 comma 3, 1 comma 3, and last 1 comma 2 comma 3, 1 comma 2 comma 3. All are possible subsets of set A. A set which has no element, a set which has no element, a set which has set which has no element, a set which has one element, two element, and three element. Count number of subsets: 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible subsets. It's a very important formula. At present we will discuss based on this. Number of subsets of a set equal to 2 power k, where k is number of elements. For example, that is also, and one more important definition of power set. If we put one more bracket for this, without bracket, these are all the possible subsets, all possible subset. So this is all possible subsets. But if I use one more bracket, and this set is called power set of A. Power set of A. See, the set of all subsets of a set is called power set, all possible subset. So this formula, if n of A equal to k, a set has k elements, its power set has 2 power k elements. Power set has 2 power k elements. And one important note, even though it contains 8 subsets, this set is called improper subset. Improper subset. Every power set or every set A has only one improper subset, remaining subsets are called proper subset. So, if a set has 2 power k possible subset, it has one improper subset equal to 1, and proper subset equal to 2 power k minus 1. 2 power k minus 1. Here 2 power k, 2 cube is 8. 8 minus 1, 7. Okay. If a set which has 31 improper subset, what is the total number of elements that original set contains? Very simple. So what is a number very close to 31 which is powers of 2? 32. Or add 1. See, this is 31 plus 1 because only one improper subset, 31 plus 1, 32, that is equal to 2 power 5. The original set contains how many elements? 5 elements. Okay. So one of the very important 1 mark question, if only the number of proper subset is given, how to find the original number of how to find the number of elements that original set contains. And very important note about subset, every set is a subset of itself. This is a symbol. And empty set is a subset of every set. Empty set is a subset of every set. Now, so in this video, we discussed what is subset and what is its definition, what is a symbol, and two important types of subset. One is improper subset, another one is proper subset. Based on improper and proper subset, what is a power set and what is a, yes, only power set, universal set, and what is universal set? Okay. Universal set symbol is U. Okay. So this concept is very important not only for points but also useful for intervals. We will discuss about intervals in separate videos, but as interval is new concept for 11th standard. Based on the subset, what is the relation between subset and interval, we will discuss in one separate video. At present we know the Second concept of classification of sets, already we discussed level 1, now this is level 2 sets. Thank you. Hello students, in this video I will teach what are the operations in sets. There are 5 different types of operations, but before that we have one important concept called Venn diagram concept. Venn diagram, this is name of mathematician, Venn diagram. We have 2 different types of diagrams. One is rectangle, another one is circle. Rectangle only used for universal set. If the identity or a problem which is related with universal set, use rectangle, otherwise no need to use rectangle. But for all subsets you can use either circle or ellipse, but always use circle. Okay. So wherever a subset is there, use circle for Venn diagram and use rectangle for universal set. Now, so what are the different types of operations? Operation 1, union, and operation 2, intersection, and operation 3, difference, and operation 4, symmetric difference, and last one is complement. But every operation you have one special operator, and what is the meaning of that operator, everything we will discuss, and we will discuss in 2 different ways. One is by using example, another one is by using Venn diagram. First, union, set of all elements which are either in A or in B or in both. Either in A or in B or in both is called union of 2 sets A and B, and is denoted by A union B. A union B, either in A or in B or in both. A union B equal to X belongs to A or X belongs to B or X belongs to both A and B. For example, A equal to 1, 2, 3, B equal to 1, 3, 4, 5. What is A union B? Either in A, write all the elements 1, 2, 3, and 1 already is there, 3 is there, now 4, 5. 1, 2, 3, 4, 5. Why these 2 numbers are omitted? Reason? Any idea? Why the numbers 1 and 3 from B is not included in A union B? Because repetition not allowed. Repetition not allowed in a set. Write all the numbers without repetition. That is the meaning of A union B. Either in A or in B or in both. This is a simple example to understand the concept of union. So union means this operation is R. Every operation, so one important meaning of that operator. Now, if you draw two circles, you have only 3 possibilities. With some common area, no common area, one set is a subset of other, that is all are common area, that is the set is inside the other set. Here completely inside, here completely outside, here's only some common area. But in geometry you have this type, but no need to apply this concept. Now, how to shade A union B? What is the definition? Either in A or in B or in both. Either in A, shade this area, or in B or in both. This is A union B. For the second case, either in A or in B, and there is no both common area, you can leave. Okay. And third one, either in A or in B, that is one set is inside, that is in A as well as in B. So this is the definition of union. What is the meaning of union? R. What is the definition of union? Either in first set or in second set or in both without repetition. So you can easily understand the concept of any set operation by taking an example or by using the Venn diagram. Okay, this is first operator, and second one is intersection. Symbol of intersection is this and meaning is and. A set of all elements which are present in both A and B is called the intersection of two sets A and B and is denoted by A intersection B. A intersection B. A intersection B equal to set of all x such that x belongs to A and x belongs to B and x belongs to B. For example, we will discuss the definition by using the example A equal to 1, 2, 3 and B equal to 1, 3, 4, 5. Sorry. What is A intersection B? A intersection B. So what is the meaning of intersection? Elements belongs to A and elements belongs to B, which means only common elements. So what are the common elements? 1, 3, 1, 3. 4 and 5 is not there in A and hence A intersection B equal to 1, 3. Only common element, whereas in union all elements without repetition. Elements belongs to both the set without repetition, but here elements belongs to both sets, that is common elements only. And if you apply this concept of this definition, how to shade A intersection B, x belongs to A and x belongs to B, that is a common element is this A intersection B. Okay, what about this? I will take one more example. C equal to 7, 8. What is A intersection C? 1, 2, 3, 7, 8. Common elements. Is there any common elements? No common element and hence it is a null set. Therefore, here you can't shade for the second case. Second case, no need to shade because there is no common area. This is an example for this. And D, 1, 2, 3, 4. And what is A intersection D? A contains 1, 2, 3 and D contains 1, 2, 3, 4. What is A intersection D? A intersection C equal to 1, 2, 3 and that is nothing but A. Here A is a subset of D. All the elements of A belongs to D and hence A is a subset of D. Therefore, the result is nothing but only the inner circle, only set A. Okay. So, this is a second definition of intersection. Intersection of two sets. Some common area is there, that is joint sets, disjoint sets, subsets. These are all the maximum possibilities for two sets. So, what is the meaning of intersection? Intersection is nothing but what? And only the common elements. Next, difference. Set of all elements which are present in A but do not present in B, which means only in A. The meaning of minus is A minus B. Elements belongs to only A. Elements belongs to only A. Set of all x such that x belongs to A and x does not belongs to B. So, what is A minus B? What is A minus B? A minus B is nothing but elements belongs to A but not in this. 1, 2, 3, here 1 and 3 is there, 2. That's all. 2. Okay. And in terms of Venn diagram, this area. This is A minus B. A minus B. What about this second case? The second case, either that is elements belongs to A but not in B, but here both are disjoint and hence only the first set. What about third case? But before that, what is C equal to? 7, 8. What is A minus C? Elements belongs to first set but do not present in second. 1, 2, 3 not present in C and hence the elements are and hence the elements are 1, 2, 3, and that is nothing but A. Yes, and hence A is shaded. And hence A is shaded. And D, 1, 2, 3, 4. And what is A minus D? One very important situation. A equal to 1, 2, 3 and D equal to 1, 2, 3, 4. What is A minus D? Sorry, A minus D. Elements belongs to A but not in D. But all the elements of A, 1, 2, 3 belongs to D, and hence there is no element in A minus D. It is a null set. Then how to shade this? 100% not possible. All the elements of A belongs to this. Elements belongs to A but not in B. But all the elements of A belongs to B, and hence not possible to shade the third figure. Okay. So what is the meaning of difference? Belongs to first set but not in second, or only in first set. Only in first set means but not in second. Third operation is over. Now fourth operation, symmetric difference. Set of all elements which are present only in A and only in B. Only in A and only in B is called symmetric difference of two sets A and B, and is denoted by delta A delta B. And meaning of this symbol delta is only in A, only in B, which means other than the common elements. Other than common elements. Other than the common elements. For example, A, B. What is A minus B? 1, 2, 3, 1, 3, 4, 5. So 2. And what is B minus A? Elements belongs to B but not in this. So 4 and 5 is there but not there, and hence 4, 5. Now in terms of Venn diagram, this is A minus B. And this is B minus A. Other than common. See that the meaning of this is other than common. Other than common. Okay. And in terms of disjoint sets, A minus B, other than common means there is no common in this figure, and hence other than common. What about third case? 100% not possible. So what is A minus B? One second, sorry. A minus B is a null set. What is B minus A? Elements belongs to B but not in A. Here this is there. This is B minus A. But there is no A minus B. A minus B is a null set. Okay. So this is the fourth operator, and meaning of this operator is other than the common elements. Next, last operation, complement. So far we discussed 4 operators, but all the 4 operators requires 2 subsets, A and B, because left side and right side of union is A and B, and for intersection left and right is A and B, for minus A minus B, for delta symmetric difference A delta B, but at present we need only one subset. A set of all elements which are not present in A but present in U. Here universal set is there. Is called complement of the set A, and is denoted by A dash, A complement, or A bar. But use this symbol in book, only A dash is there. So X belongs to U and X does not belongs to A. For example, A is set of students passed in maths exam. What is the complement of A? Failed in maths exam. But the combination of passed students and failed students is nothing but the class 10th, and that is nothing but what? Universal set. Okay. The combination of A and A complement is nothing but, that is union of a complement, union of a set and its complement is nothing but universal set. So, for example, A equal to 1, 2, 3 and U equal to 1, 2, 3, 4, 5. What is A complement? does not belongs to A but belongs to U. So 1, 2, 3 belongs to A, only 4, 5. Okay. But for this case, the Venn diagram concept is entirely different. Already we'll discussed in the beginning of this video, for universal set, then symbol is, that is diagram is rectangle. And this is A. And then what is A complement? This is A complement. A complement, okay. A complement. Set of all elements which are present in A, which are not present in A but present in U. This is complement of sets. And two important types of sets which based on these two operators, particularly intersection. Two sets are said to be disjoint sets if they have no common element, no elements in common. For example, A equal to 1, 2 and B equal to 3, 4. 3, 4. So what is A intersection B? A intersection B is a null set. So A and B are called disjoint sets. Two sets are said to be disjoint if they have no common element. And what is the complementary of disjoint sets? If they have at least one common element, then those two sets are called overlapping sets or joint sets. Two sets are said to be overlapping or joint if they have at least one element in common. That is the definition of overlapping or joint sets. So in this video, we discussed the basic operations of sets, 5 operations. Operation 1, union, and the meaning of union is or. Operation 2, intersection, and its meaning is and. And operation 3, difference, and meaning is only in the first set. And operation 4, symmetric difference, delta, and the meaning is other than the common elements. And operation 5, complement of a set. And we discussed each and every definition by taking an example and by shading a Venn diagram. Now at present, you are clear in the basic definitions of all the 5 operations. Thank you.